The Storm Prediction Center has issued a moderate risk of severe weather for later today, November 29th, 2022, and there could be a tornado outbreak. So in this video, we're going to look at the individual characteristics of the atmosphere which may support this dangerous risk of severe weather. And we're going to start with what's happening right now actually. Mesoanalysis page, surface pressure and pressure change does show the surface low over Kansas. Pressure falls ahead of it, tightening isobars. That is depicted here. The Weather Prediction Center surface fronts and sea level pressure map. Later in the morning, that surface low is right here over central parts of Kansas, and it progresses off to the northeast. By the evening hours, we're all the way up into the upper Midwest, and it's going to be deepening continuously as it does so. Now notice that is pretty well removed from the severe weather risk area that's way down here in the deep south, the surface low being all the way up here. But we do have this cold front that stretches across parts of these southern plains into the Midwest. That's going to be advancing into the region, but we're looking at prefrontal storms ahead of this. That's what we're really concerned about. And the surface low, although it's not that close, does play an important role because it's going to be continuously deepening. That pressure response advects moisture and warm air northward across parts of the deep south, the Ark-La-Tex area, Ark-La-Miss, and this is going to be really increasing the moisture and temperature, which we can combine with this parameter, the surface theta E. So by 03Z, this is well into the evening, we're headed into probably early overnight, pretty soon here. The axis of theta E is right here. Theta E is stretched right here over parts of the Mississippi River into Mississippi, still over parts of Louisiana as well. And we're also going to have some EML influences actually. This is the elevated mixed layer, which you can see here actually starts off in parts of southern Texas, coming off of northern Mexico. It's going to be advected northeastward by strong southwesterly flow aloft over parts of Arkansas, Mississippi, Louisiana by late in the evening. So we've got some pretty good lapse rates going on here actually across this corridor. 7 to 7.8 degrees Celsius per kilometer certainly seems reasonable. Now, when we combine this significant moistening taking place during the day and the steepening mid-level lapse rates, we do end up with some fairly substantial CAPE for the time of year. So 03Z again, later in the evening, a pretty substantial plume of mixed layer CAPE, which is on the order of 1500 to maybe close to 2000 joules in some places. It seems more likely will be closer to 1500, but this is what we're looking at in this area spreading into central and northern Mississippi and through the Ark-La-Miss region. Now that's the thermodynamic side of things, but one aspect that we're really going to be paying attention to is the wind shear. This is the effective bulk shear that is being presented here on the weathernerds.org map. And we see by 20Z we're really ramping up already. That's because we do have a split flow regime, which I can actually show here in a moment. But we have these jets that are amplifying. I apologize for that thing. Spreading over parts of the Ark-La-Miss area into the mid-Mississippi Valley, and by late in the afternoon, in the evening hours, we've got very strong effective bulk shear through this region. It is really on the order of 60 to 70 knots in some places. So all through this region, where it is marked in orange and yellow, we're having values above 50 to 60 knots. That's favorable for organized storms. Now, another aspect of this is going to be the low levels. I can actually take a look at the mid-levels first because I do want to show we do have the split flow pattern with the main trough out here over parts of the Rockies. You can kind of see that coming out, ejecting over the Rockies. That's responsible for the surface low development right now. But as we play this forward, it becomes a little more clearly defined that we can see this stronger jet streak, or stronger jet stream I should say, right up here, the northern jet stream, and a weaker southern jet branch across parts of Mexico, Texas. This is advecting that elevated mixed layer air as I mentioned earlier. But as these move along, they will combine, and we really do see that amplification of flow as the jets combine over parts of the Ozarks into the Ohio Valley. This is a situation kind of like on a synoptic scale like we saw last December on the 10th. There have been analogs compared to this, but I'm not saying we're going to see another December 10th, 2021. This is just to say that as these individual jet stream branches in the split flow combine or get closer together, we will see flow in the mid-levels of the atmosphere really start to intensify. That is what's increasing the wind shear through a deep layer. Now, another aspect of this that's really important, 850 millibars. this is the approximation of the low-level jet. The surface low is coming out into this region in Kansas. It's deepening. As it does so, the pressure gradient force gets stronger, and a massive low-level jet starts to develop by parts of the evening over a very extensive area, all the way from the Louisiana, Mississippi area into southern Canada. And this does include the Great Lakes, so we've got very strong winds. Spreading over this area could be in excess of 60 to 70 knots. So that's really ramping up your wind shear. And that translates to low-level wind shear. So we look here, this is effective storm relative velocity in the colored areas. The lines represent surface-based convective available potential energy. This is again by Weather Nerds, a fantastic site. I will be providing links for these in the description as well. But we play this forward through the afternoon. Already a fairly good combination of ingredients coming together over parts of Mississippi and surrounding areas. This is where we've got increasing low-level shear and increasing instability. That is combining favorably, and as we head into the evening, it strengthens further. The further we go eastward, the more the low-level shear is going to strengthen, and we have that tornado risk really heightened into parts of central and northern Mississippi during the evening. Spreading into Alabama, we start to get less and less instability, but you will still maintain some severe weather into at least the western parts of the state. Now, I did mention before, we are somewhat removed from the surface low. We're removed from the cold front as well. That's represented here. This is going to be your 925 millibar relative humidity and streamlines. These streamlines are very important because they can show us where air is trying to converge, and this could signify prefrontal confluence bands. And it seems like as we head into parts of the late afternoon, we have one of those confluence bands developed right around here. The confluence is very important because it can initiate discrete convective modes. It's a less forceful lifting than along the cold front, which would tend to favor more linear storms. So that could initiate some discrete storms for us, and in fact we could see several given the atmosphere that we're expecting. Now this is 0 to 1 kilometer EHI, Energy Helicity Index. This is essentially combining CAPE and helicity to see where they combine favorably, and that gives you an idea of your instability and your wind shear overlap. Now this is the parameter space that is being depicted by this particular model, the NAM. A couple of things of note here is the wind shear is very intense in the low levels. That is some pretty substantial hodograph curvature, stream-wise to storm motions largely. That's going to be leading to very large values of wind shear. You can see over 300 in the SRH in the 0 to 1 kilometer layer. But look at this too, the thermodynamics. A deep, moist layer with high relative humidity, low cloud bases, low LFC heights, and a pretty good layer of instability. Now that's going to be leading to an environment, when you combine with this deep layer shear, that is favorable for deep updrafts that are affected by very strong wind shear on multiple levels of the atmosphere. So here's what models think. This is the RRR, what will happen. This is just one depiction of what could happen. It might be different than this, but this is one idea of what might happen to thunderstorms developing in this kind of environment. Now we play it in the afternoon. We start to see storms gradually intensify. They will start to take advantage of the deepening boundary layer. And by late afternoon, here we go. We are starting to acquire some of these discrete storm modes, some updraft rotation starting to develop as well. This is going to start off in northern parts of Louisiana and southeast Arkansas before spreading into northern Mississippi. As we play that forward too, later on in the evening, we see the risk continue, because again, as we head further east, we're going to be seeing increasing low-level wind shear, so you see that spread into northern and central Mississippi. That is one, and you see many of these. I'm sorry for that piece of crap again. We see many of these discrete storm modes, so I would say you are under a considerable risk for severe weather in this area right about here. That's where things do seem to be coming together favorably, and we could see some long-tracked significant tornadoes because of the strength of the wind shear. So that's been a severe weather briefing on this dangerous severe weather risk today. Have a way to receive warnings. Make sure you know your weather radio is plugged in and charged, and be on top of this situation, because we could be seeing significant long-track tornadoes at night, and we could see several of them. This has been a severe weather briefing, and I hope you stay safe tonight.